This sample problem is on spring force or Hooke's law. A mass of 125 grams is attached to a spring of spring constant K is equal to 58 Newton per meter that is hanging vertically. First question, find the extension of the spring. So if we are going to draw this one, we have a spring hanging vertically like so, and on this spring we have a mass of 125 grams that is attached to it. And we need to solve for the extension of the spring for the first question. So recall that spring force is equal to Fh is equal to negative Kx, where the negative sign here tells us that the spring force is a restoring force. So for example, if this weight of the object is pulling the spring downwards, the spring force would actually exert an upward force. So this is our Fh, and this is the applied force or the load. So once again, the negative sign here only tells us that whatever the load is, the spring is going to exert a force opposite to the direction of the applied force. Hence, if we are just interested in the extension of the spring, then we could just remove the negative sign. So we will use the equation Fh is equal to Kx. Now, we need to identify our applied force. So once again, our applied force would just be equal to the spring force or the Hooke's law force. In this case, the applied force is equal to the weight of this object. And the weight of this object, Fg, or the weight of the object, is just equal to the mass of the object multiplied by the acceleration due to gravity. And we must make sure that we change the mass from grams into kilograms. So once again, the applied force or the spring force is just equal to the weight of the object. So that is going to be mg is equal to k times x. So the mass is 125 grams. We need to convert that into kilograms by dividing it by 1000. So the mass is 125. We divide that by 1000 in order to change it into kilograms, times 9.8, which is the acceleration due to gravity, is equal to the spring constant, which is 58 Newton per meter, multiplied by x, or the extension of the spring. We put these values in the calculator. X is equal to 0.021 meter. So once again, we need to remember that the magnitude of the spring force is just equal to the magnitude of the load or the applied force on the spring. So in this case, the applied force on the spring is just equal to the weight of the hanging object, and therefore the weight of the hanging object will be equal to the spring force.